Good day everyone. I want to introduce you to a project in which we desire to use quantitative real-time PCR to determine the efficacy of fungicides. This is specifically for use in pears. We all know fungicide efficacy depends on multiple factors. Two major factors include the efficacy of the active ingredient, as we know, and also how effective the fungicide is applied pre-harvest or post-harvest. Now, molecular biology, or in our case, real-time quantitative PCR, is an accurate and sensitive method to quantify fungal spores, and we desire to use this method to determine fungicide efficacy. Working with DNA, it's obviously we need to build in a time scale, and based on the amount of growth, whether it is vegetative or reproductive, after application of the fungicide, we can then use that to see if the fungicide was effective in inhibiting or killing the spores from the start. Specifically, I want to look at botrytis on pears, but this method is not only important for post-harvest pathogens, but can be of great value for obligate pathogens that cannot be cultured, such as your powdery mildews or your rust pathogens. So in short, we would like to use this technology to determine the efficacy of fungicides. To run you through our materials and methods, firstly, we want to see if there's any interference with the fungicides with the DNA extraction process. This was done. We didn't experience any problems. And secondly, we want to see what tissue type would be ideal for our testing. This includes leaves and, of course, the fruit, whether it's the stem end, the calyx end, or the skin. These samples have been processed. It's currently frozen for further processing. So the primer probe set, which is next, we got it from an article. So those primers and probes were ordered, but we had to just to check the primer efficacy and R-square value, which didn't show any problems. And we also had to confirm with the template and the primer concentration what annealing temperature would be ideal. So all of this has been done. I will show a bit of the data as we go on. So after this, we looked at the host primer probe set. So this is specifically important to normalize your data based on the sample you use, to tissue sample that goes into the processing, and it also gives a good normalization from sample to sample to properly compare your data from what you quantify the botrytis from. This is based on what we saw from article. This primer probe set has been ordered. It's currently in our possession. We still need to optimize it though. And after we've done that, we would like to optimize it with a multiplex to see if this is possible, just to simplify our PCR process as we go on with this. And finally, we want to look at fungicide efficacy tests. Firstly, just a small time trial to see any increase in growth based on your 1 hour versus your 92-hour incubation of your spores on leaves. And then with that, we would do our full-scale fungicide efficacy test using different time frames, and of course, we also would look at different treatment concentrations to give an indication of application method. This is just an illustration of a series solution of the botrytis primer probe set. So we had good clustering of our reps. It's a very positive indication of reproducibility. We had a good R-square value, which is close to 1. And the primer efficiency was close to 110%, which is where we want it to be. So we were very happy with the results. This is an illustration of the final test, the fungicide efficacy test. Like I mentioned, there are different intervals and different treatment concentrations. And based on how this runs, you would see a difference in the spore quantification, or the cells, the amount of cells we detect. And this will help us to determine the efficacy of then two different fungicides and application methods of them. This is just the plating of that test. We've already done it, and we can see a gradient effect here. Although you see fungal growth here, it's not necessarily from botrytis. It can be from any endophyte or fungi that were not killed by the treatments we used. So everything has been done. We just need to finalize our qPCR process and run the results. Thank you.